Hi ladies, in this video we're going to go through 11J, which is only one question. It's like an extended response question, so goes right up to I. So a few questions within there. With this question though, it does require you to use the map in your textbook, because for question A you actually have to measure the line, and if it's on your screen it's probably not going to be the same distance. So I've got my ruler here. It's a beautiful blue smiggle ruler with rainbows all over it. Kind of reminds me of the Care Bears, but I'm going to use it for this question. If you've got a ruler, you're going to have to use it to measure the sides of the triangle. Okay, so Alice operates a charter flight service for country Victoria. She is planning a round trip from her base at Bendigo to Shepparton, Ballarat, and then returning to Bendigo. So you can look on that map. Bendigo is, do you know, I was just about to point at the screen because you guys can see me pointing. Bendigo, what am I doing? I can do it with this, is here. Okay, so she's going from Bendigo up to Shepparton and then going down to Ballarat and then going to Bendigo. Okay, so the direct distance from Ballarat to Bendigo is known to be 85 kilometres. So from Ballarat down here to Bendigo is 85. By measuring the lengths of the blue lines between the three cities, calculate the direct distance from Bendigo to Shepparton and then Shepparton to Ballarat. So I'm just getting my ruler. So from Ballarat to Bendigo, and we just got to kind of be accurate. Now you can say, oh, it's about 5 centimetres. You're not going to get the same answer. So it's 4.7 centimetres. So I'm going to draw the triangle over here. Now it's not going to be the best triangle. It's looking all right so far. Nope. Okay, so this side here, when I measured it, it was 4.7 centimetres. And remember, in the question, it said that equates to, and I'm going to do it in a different colour, because you all know I like colour. What is it, 85? So I'm going to put 85 here. Okay, so 85 kilometres. So you're kind of working to a scale. Now, from Bendigo to Shepparton, we've got 5.1. I'm going to call it 5.1. Okay, 5.1 centimetres. And then from Ballarat to Shepparton is, oh, is that exactly 9? Is that nice? Nice if it was 9 centimetres. Okay, so I've got 9 centimetres here. All right, so what is it asking? What do we actually have to do? So we measured the lengths of the lines between the three cities, and we've got to calculate these other two. So if I know 85 kilometres is 4.7 centimetres, we've got to work out what these other two lengths are. All right, so if I take 85 and divide that by 4.7, so on my great calculator, so we get 18.0. I'm going to do it to a few decimal places just because, you know, I feel like I need to be accurate this time. Not that I'm never really accurate, but more accurate this time. So this basically means 1 centimetre is equal to 18.085 kilometres. So for this side here, we've got 5.1. So we're going to multiply that by 18.085. So just doing that on my calculator, times 5.1. I say calculator because I did a video before this one, so you probably haven't seen that video before you did this. Watch this one. I actually talked about my calculator is my phone. So when I say calculator, I'm not really using my calculator. I'm using my good old iPhone 6 that I've had for nearly 5 years, which I'm really proud about. Okay, so this length here, 92.23. And then let's do from Shepparton to Ballarat. So we do, 9 times 18.085. My handwriting's neat. I'm probably going to jinx myself now. Okay, so 9 times 18.085. I've been listening to a lot of podcasts over the break, so 3 weeks. So I walk nearly every day and I listen to podcasts. I don't listen to music because that's what old people do these days. They listen to podcasts. And now I feel like I'm in my own little podcast when I do these videos. All right, so let's just go and check our answers because I measured using my good old Smiggle calculator. Oh my gosh, how can I be so far out? Oh, that's not good. I'm going to pause and just figure out where I went wrong. All right, now the difference between my answers and the textbook's answers is clearly in measuring those lengths. So they used 4.6 here. So I might actually just take you to the answers. So you can see they've written in millimeters, but it doesn't make any difference. So 46 millimeters. So the factor they're multiplying by, I'm doing 18 point, I wonder if the value is still up. Oh gosh, come on. I'm multiplying by 18.085, but if you're dealing with 4.6 or 46 millimeters, you're multiplying by 18.478. So that millimeter makes a huge difference. And when you think about it, with changing that millimeter into kilometers. So the answers actually aren't too, well, they are a little bit off, but that's the reason why. Okay, so you can see here for part 1, or part I, it's 94.2. So that's because of this 4.6 here. I measured the 5.1 right, but here they've written 89 and I wrote 9. So I'm very close. And the main reason for the difference is just ruling or measuring those lines. So you may have got something quite similar. Just depends on how you measured your blue lines. Okay, I'm not going to go back and change it because there's nothing wrong with the maths. Just while we're on this question though, this is a question that you're probably not going to likely see on any assessment, because when you think about it, I've got a different answer to the textbook because I got 2 measurements different. Even if you got one different, then the person sitting next to you may have got a different one different. So there's multiple different answers you can have. So you're not going to see this on an assessment, but we're going to keep going and we're going to use the answers from the textbook because I'm assuming that we're going to have to use these answers again, do we? Well, if we do, I will use them. I'm just trying to see. Is this 85? Yeah, so they've used the 94.2 here. Okay, so we do need to use the values from the textbook just so we're consistent with our answers. Otherwise, we're going to have different answers all along. Doesn't mean that they're wrong. It just means that it's just a measuring thing. Okay, so let's just write it here. So from Bendigo to Shep, it is 94.2. And then from Shep, listen to me, I'm like a local. Yeah, good old Shep to Bal. What is that? 164.5. Okay, so we're going to use those values from now on, not the ones we did before. Otherwise, our answers are all going to be different and it's just going to be annoying. Okay, so question B. Her Piper Archer TX, I assume that's a plane, has a range of 522 nautical miles. 1 nautical mile equals 1.85 kilometers. The fuel gauge indicates that the tank is 1/3 full. Is there enough fuel to complete the round trip? So the whole trip, let's just do that first. So remember, they told us from Bendigo to Shepparton is 85. So it's going to be 85 plus 94.2 plus 164.5. Okay, so let's just add those together. our iPhones, 85 plus 94.2 plus 164.5. So the whole trip is going to take her 343.7 kilometers. Now we're given nautical miles, so let's work out what that is in kilometers. So we're going to do 522 times 1.85. 522 times 1.85. So that's 965.7. So that's what she would have on a full tank. Okay, so she can do that in a full tank, but it's only 1/3 full. So we've got to divide that by 3. So 965.7 divided by 3, because she's only got 1/3 of the tank, 321. So is she going to make it? This is how far she's got, and this is how much fuel she has. So the answer is no, she's not going to make it. All right, so the next one, question C. So the average cruising speed is 147 miles per hour. 1 mile equals 1.61 kilometers. Find the total flight for the round trip. So again, we've got to convert it. So I know we've got miles and nautical miles. Don't ask me the difference. I have no idea. But you know who does know? Google. So if you're really keen, I probably shouldn't say that. But yeah, I'm not sure. I mean, I could say something, but I'm probably wrong. So if you really want to know the difference, yeah, I don't know the answer. So 236.67 per hour. So that's the speed. 236.67 kilometers per hour. Find the total flight time for the round trip. So we need to use the formula speed equals distance over time. So you may have used this before, maybe in science. So speed equals distance over time. So it's kind of like your speed is 336.67 kilometers per hour. So our speed, 236.67. The distance, which we did before, 343.7. And then over time. So time is what we need to work out. So we're solving for time. So we can just switch these. So time is equal to 343.7 over 236.67. Okay, so that is, let me just do that on a calculator. 3.7 divided by 236.67. So we get 1.45. Now, if you want to do that in hours and minutes, so that's 1 hour, and then we've got 0.45 times 60 minutes. Oops. So it's 27. And 27 mins. Very rarely you'll have to do that conversion, but you do need to know how to do it. So there we go. What are we up to? D, fuel consumption cost is 95 cents per kilometre. What will her fuel cost for the trip? So she's travelling 343.7. It's 95 cents. So let's do 0.95 because we're going to put the answer in dollars. So 343.7 times 0.95. So we've got 326. God, that's cheap, isn't it? And because we're working in dollars, we'll just round it to 2 decimals. What are we up to? E. If a vertical line points north, use the map to find the bearing that Alice must fly from Bendigo to Shepparton, Shepparton to Ballarat, Ballarat to Bendigo. Okay, so this is a bit annoying. It's a bit of a bearings question. Maybe we'll do a new page for this. Okay, and I need the map, so we'll scroll. Okay, so a vertical line points north. Use the map to find the bearing. Okay, so let's draw the triangle first. Actually, no, we don't need the triangle. Oh, we might need the triangle. I'm thinking as we're going. So we're going to do Bendigo to Shepparton first. So let's draw that. So there's Bendigo. And all right, Ben, because, you know, we've got Ballarat and Bendigo. I don't want to just use B because we might get a little bit confused. And there's Shep. Oh, how perfect is that line? And then, oh, another perfect line. I'm on fire. Okay, so this is the bearing we want to find for the first one. Okay, so the bearing that she must fly from Bendigo to Shepparton. Now, to work out what that is, I'm going to draw the rest of the triangle in pink. Sometimes I choose different colors and I don't even know the rationale, but because we're doing this bearing and we need this triangle as well, we do need to, what do we need? Gosh, this is tricky. Let me just think. Okay, so angles within the triangle do help and our distances do help. So maybe we'll put those on as well. So what have we got? I know this is 85. This distance from Bendigo to Shepparton, what was that? 94.2. And then I might just pause because otherwise you'll... Now, I have been thinking about this question. Unless you've got an angle, you actually have no idea what the bearing is. So because this is an actual map, you can actually find this angle just using a protractor. So I've just looked at the answers because, you know, when you're a bit stuck, you can use the answers to help you. And there's no working out. So the only way I can work out that they've got that bearing is using a protractor. And when I'm looking at this in more detail, you can't find that angle without a protractor. So if I just quickly show you the solutions, so you can see they're 69 degrees. So if you had a protractor, you could use that to work out that that is 69. So your bearing is 069 degrees. Now you could use a protractor for the rest of them as well. So what I'm going to do is, because you can't physically see me putting a protractor on there, I'm going to show you what bearings we need. So we just did the first one. The second one is Shepparton to Ballarat. So I'm going to draw that line. So we've got Shep to Bal and north pointing up. So we don't actually need our triangles. And this one here, let me just do it in a different color. When you're using your protractor, you're finding that angle there. Now, if you've only got a protractor that goes to 180, so you can get protractors that go to 180, or the one I gave you is 360, so that's good. You could actually use that. And again, I'm just going to show you the answer because I can't physically put a protractor on the screen. So 226. So this angle here is 180 and this angle here is 46. So altogether, it gives you 226 degrees. And then the last one, we're going from Ballarat to Bendigo. Okay, so we're going up kind of like that. So there's Bal and there's Ben. So this time we're going up north here, and we want this angle. So use your protractor, and I just had a sneaky look before. It's 21 degrees. Okay, so you need a protractor for that, but I remember I gave you all one on transparent film. So hopefully you've still got that and you can use that to answer question E. Okay, still going. Question F, give the direction and distance flight information that Alice will need to use on the Shepparton to Ballarat stage of the circuit. So Shepparton to Ballarat. So what would we tell the plane? So the plane needs to fly on a bearing of 226 degrees for, what was it, 164.5 kilometers. And I'll just show you the answer. Fly 164.5 kilometers on a bearing of 226. Good. Okay. Question G, use your answers to part E to find the angle between the flight paths to and from Shepparton. So the angle we want, and it's probably good, here's a triangle I created earlier. We want this angle in here. Now you can use the triangle without any of the bearings. Okay, so we've got these distances here. So you could use the cosine rule. So we want to find theta. I'm just going to cheat again and have a look at the solution and see whether they've actually put the, oh no, what did they use? Oh, I see. Oh, no, they didn't use the cosine rule, although you could use the cosine rule. What is H? Yeah, so G. Yeah, so G, you could use the cosine rule, but what they've done is just the knowledge of angles. So this is this line here. If we draw another, we draw another vertical line. This 69 is this 69 here. Why does it do that? And then we know that this angle in here is 46. So that's why your solution has 69 minus 46, which gives you 23 degrees. So this angle in here is 23. But you can use the cosine rule as well. Okay, question H. Let's have a read. Show how a trigonometry distance rule can be applied to the Bendigo, Shepparton, and Shepparton Ballarat distances with the angle at Shepparton to find, to find the Ballarat Bendigo distance. Confirm that the distance is approximately 85. All right, I'm going to cheat and just have a look at the answer. So we know Bendigo to Shepparton is 94.2. So we've written that on here. Shepparton to Ballarat, 164.5. We know this angle here, 23. So it's basically asking us to prove that this is 85. Okay, so here's your working using the cosine rule. So they've just called this distance here between Bendigo and Ballarat A. So B and C are other two sides, and the angle A is 23. So there's your cosine rule. And it's kind of close to 85, so 86.4. Okay, so that's what they're requiring for question H. I'm getting a bit slack on, I'm referring to the solutions. Find the area enclosed by the flight paths. Oh, so you'd use Heron's formula. Oh no, what have they used? Oh no, they've not used Heron's formula, they've used the other formula. You could use Heron's formula, but because we know this angle is 23. Okay, so half BC sine A is, so you've got three formulas for the area of the triangle. Half base times height is what you are used to using. And this is quite similar. You're just using the two sides and the angle. So half BC sine A, and there you can have it. So those two angles. So this question here requires you to measure the lengths using a ruler and the angles using a protractor. So if you got a different answer to the textbook, it's not necessarily that your maths is wrong. And I don't want to say that you can't measure a straight line, because we all know that I differed to the textbook, but only by a millimeter for each one. So your answers, unless they're way off, just take it, that say, oh yeah, I'm good. I know the maths. It's just I was out by a millimeter. All right, girls. Bye.